Hi, folks. I'm Mr. Morin, and I'm going to try to walk you through a transition from the amazing work that you did this week with proportions and similar figures into an application that gets used by folks called surveyors all the time. And so, the idea is that once we have this understanding of similarity and we can use these proportions, we can measure things out in the world that are really hard to measure by just walking over and taking a tape measure. Maybe they're really, really tall, maybe they're really far away. So here we're going to sort of walk you through some basic examples into a real application that I think will resonate with you. So here we go. I'm going to start out with this example and just anchor in the idea of what success looks like. Remember that what we're trying to get to is we want to try to be able to use similar triangles to measure something that's hard to measure. And remember, the way that we led into this idea was by starting by thinking about a line and thinking about slopes and slope triangles. So what I've got to just sort of start our discussion here is this line y equals 1/5 x. And so that's this red line that I've drawn here. Okay, so that's this red line here. And I've labeled it to make sure that you can see, okay, that's what that equation of that line is. What I've done is we looked at a whole lot of different slope triangles, and we know that we could choose lots of different nice points along that line, and that different students choose different points when they're doing those slope triangles. And so I've got this small slope triangle that's 1 to 5. That slope would be rise of 1, run of 5. I've got this other one, 2 to 10, keeping in mind that this 10 is all the way back to the vertex, okay? It's not, it's not related to this particular triangle here, okay? So this rise is 2 and run of 10. And I could draw a nice big one, 6 by 30. And so what we talked about and what we looked at this week was the way that when we write that rise over run, if we use the small triangle or the green medium triangle or the big blue triangle, it's still going to be a ratio of rise to run that is equivalent, even though those numbers look different. And we talked about the different scale factors that we could use to think about how to get from one triangle to the other. And that's a big part of what similarity is really about. These are the same shape triangles, but they're a different size. They've been scaled up or scaled down by a scale factor. So we've multiplied by some scale factor. Now, we can take this, this setup here, and we can actually go and extend it even further. So you can see my graph here ended at like 30. What I've done is I've extended it to 90. And I'm going to ask, okay, so what if I have these slope triangles and I've got this point that's on that line, that same y equals, this is still that line, y equals 1/5 x. But I ask, where would this point that's 90 units away from the origin, 90 in the x, what would the y coordinate be? And so what we can do here is we can actually use similar triangles to find that piece. Now, we know that since this is on this line, I could put 90 in here and I could calculate it. And if we did, let's just start off and think about what that answer would be. Okay, if I put 90 in here, that would be 90 divided by 5. Well, okay, let's see here. 90 divided by 5. Well, I think it's going to be 18. Okay, our equation tells us that that's what that should be. But the work that we did with similar triangles should give us another way to find out what that height of that slope triangle, that big, huge black triangle there is with 90 along the base. So what I've got here is a setup with similar triangles, and I've got this. I chose the medium one that we drew on the original drawing here. I chose this big one, 60 by 30 or 6 by 30. And since we scaled this up, now that looks a lot smaller on my drawing here. So this is 6 by 30, and that rise over run should be the same when we do this big, huge triangle with 90 on the bottom. So something, our rise, over 90. So what I've got is a proportion here, 6 over 30 for the rise over run here. Let's go ahead and label this on the graph here as well. So this is the 6 and the 30. And you can see that I've taken these triangles out and brought them down so that you can sort of see, okay, I'm just looking at these two triangles and I'm wondering, what's that scale factor? Okay, what's that scale factor to go from 30 to 90? And it's kind of clear, it's kind of obvious with those numbers. That would be a scale factor of 3. So I'm also going to multiply that 6 times 3. Now, I also want to make sure that we sort of connect with the other mathematical way that we did these proportions. If I have 6 over 30 equals x over 90, like I did when I set up my proportion here, I can also do that sort of, butterfly technique or multiplying along the diagonals there. And I can multiply 6 times 90, and I can multiply 30 times x, and I get this 6 times 90 is 540, 30x here for 30 times x, and then if I solve that, well, guess what? I end up getting that same answer, x equals 18, whether I did it with this proportion or whether I did it with this proportion, or if I did it with my equation, which we did just to start out our thinking. Okay, so what we can see here is that this can be used when we have a triangle with sort of a missing piece we want to know, okay? And we solved some proportions in our practice this week that didn't have the drawings, where we had a missing piece of one of those fractions. So what I want to show you is that this can actually be applied to a situation where we want to measure something that's really hard to measure. I'm not climbing all the way up the tower to measure from the ground all the way up to the tippy top of that tower of East High School. But what I can do is I can stand way out by like York Street, so like right around here, here's the map from above, okay? I can stand right here. This is the student parking lot, and then just across the street, I could stand right somewhere in here, okay? And I'll show you in the drawing here again. I can stand here, I can put my camera down, and if I line up the lens of my camera, so I look through my camera and I line up the top of my head, so here's the top of my head here, here's the top of my head right here, okay? And let's say this person is 6 feet tall, and I measure, because this is a short distance, I measure that I'm standing 30 feet away from where my camera is. But I've got my camera pointing up, and when I look through my camera, I'm lining up the top of my head with the top of the tower, the top of East High School, okay? Well, then what I have is sort of a setup like this, and I sort of put it on graph paper here. Here's East High School that extends up here, and then here's the top of my head, and I'm saying I'm about 6 feet, and I've lined up that camera lens so that I can see that that's a straight shot from where the camera is on the ground all the way up to the top here, and it's a straight shot all the way up top of my head. Okay. Now, basically what this looks like off of the graph paper so that you can see it a little bit easier is basically what I've done is sort of line up these triangles in this way. Okay. So I've got the top of my head lined up with the top of the big, huge tower that I want to measure. Now, there's still one piece that I'm missing here, okay? Because I have to know something about this big triangle here. So what I did was I walked from the base of the school out to where I put my camera, and I just sort of counted my steps. Another way to do it is if you go into Google Maps, here is at the top here. If you go into Google Maps, you can actually, there's a little feature if you right click, you can measure here and you can click 2 points and it'll tell you how far it is. So this is, I couldn't get it to be exactly, my hand wasn't too steady on the mouse. So I couldn't get it to be exactly, but you can see it's 899.9, I'm going to call that 900 feet. So this is 900 feet away where I put my camera here. And here is where I am, I'm 30 feet away from the camera. And so what we end up with is these two similar triangles. Well, we know how the math is going to work. We did it in this example here with the smaller number. So here's how the math is going to work for these two similar triangles. I'm going to go ahead and set up this proportion. So again, I'm sort of thinking rise over run again. So here's my rise over my run. My rise is 6, my run is 30. And then for my big triangle here with the east tower, well, that rise is h. I don't know what it is. It's some height that I'm looking for over 900. So I've got 6 over 30 equals h over 900. And again, I chose to do the sort of butterfly technique, that sort of multiplying on the diagonals. So 30h is equal to 6 times 900. So here's my equation. That 6 times 900 is 5,400. Divide both sides by 30. And what I find out is that tower that I couldn't measure otherwise, I couldn't just walk up all the way up to the tippy top and bounce on the top of that East High School and drop a tape measure all the way down. I can measure that indirectly by using these similar triangles. And what I find out is that the tower is about 180 feet. Now, I've actually done some research, and it is very, very close to that value, almost exactly. So that's our transition from some sort of like fully mathematical, no story, no picture kind of similar triangles, just sort of triangles out in space, to what it looks like when we use this out in the world, okay? And so my challenge for you this weekend, the assignment for you this weekend, is to try to replicate that setup. And I want you to measure something that you couldn't or wouldn't normally go and measure with a tape measure. And so remember, this is going to be your setup, and we'll actually have a sort of a graphic organizer that we'll give to you. And I want you to take your camera, take your phone, and carefully lay it down on the ground. Have a friend guard it for you so nobody steps on it. Okay? Have them lay down so that they can line up and look at the sight line so that they line up the top of your head with the top of the object that you're measuring. Then I want you to measure the things that you can measure. So how tall are you? Measure it with a tape measure. How far are you away from the camera? Measure that with a tape measure. Okay? So now you're going to have the smaller triangle. And then I want you to sort of estimate how far the camera is from the bottom of the object. That might be a bigger, longer distance. And so you might have to just take big steps. So if you take a big step, maybe that's about 3 feet, and you can just sort of count those off and sort of estimate that base distance. I want you to do this indirect measurement. Take a picture of it, write your math down, and that's going to be what I want you to submit for your assignment for this weekend. Good luck with it. I'm looking forward to seeing what you guys measure. Be good.